Okay, the last lecture associated with Chapter 8 in our water discussion is the application of what we have learned about acids and bases to understand some phenomena that are happening in the environment, specifically ocean acidification and acid rain. So this is a diagram that I showed at the end of the previous lecture, looking at the pH of various solutions. We said pure water is 7, seawater is 8, and normal rain is about 5.3. We're going to look at some phenomena that result in decreasing the concentration in rain, decreasing the pH in rain, so increasing the hydrogen ion concentration. And we're going to also look at some reactions that change the pH of seawater. So let's first look at seawater. Under natural conditions, seawater has a concentration around 8. The chemistry controlling that pH is a little complex, but is summarized in this figure. You don't need to know the specifics of this reaction, but what is important to understand that the acid-base chemistry in ocean water is controlled by 2 factors. One factor is the presence of calcium carbonates and carbonates in the water. This calcium carbonates will dissolve and react with some of that acid, making the solution more basic. You also have carbon dioxide influencing the pH of all waters, but in this case, we're going to be talking about seawater or ocean water. When you have carbon dioxide in the gas phase in the atmosphere, that is in contact with water and it will dissolve in the water. When carbon dioxide dissolves in water, it forms carbonic acid, H2CO3. Carbonic acid dissociates in water and gives us some hydrogen ions. Remember, you increase your hydrogen ion concentration, you decrease your pH. So what is happening that is associated with climate change and is an increase in carbon dioxide in the atmosphere. This is increasing as a result primarily of from the combustion of fossil fuels, as we've talked about previously in this course. We're increasing our carbon dioxide concentration, which results in more carbon dioxide dissolving in the ocean, creating a more acidic solution. This is known as ocean acidification. The pH of surface water in the ocean is decreasing as a result of increased carbon dioxide concentrations in the atmosphere. And this is problematic because it can affect aquatic life, especially aquatic life that relies on the formation of this calcium carbonate, such as corals or mollusks that have calcium carbonate shells. The other area in our environment that acid-base chemistry is extremely important is our discussion of rainwater. Rainwater has a pH around 5.3, 5.4 if there's no pollutants added to it. When we add certain pollutants, and we'll look at these pollutants in a minute, we can lower that pH, and acid rain is defined as any rain that has a pH lower than 4.3. In this area of the country, we see rain that is characterized as acidic rain as a result of industrialization, specifically a lot of coal burning fire electricity generation on the East Coast in the Ohio Valley. This results in the pH of rain being lower than what would naturally occur. So what are the compounds that are causing this decrease in pH? This is associated with the atmospheric pollutants that we talked about at the beginning of this course, our sulfur dioxides and our nitrogen oxides. Our sulfur oxides, our SOx, and our NOx, our nitrogen oxides. So this is several different compounds that are emitted into the atmosphere from car exhaust and coal combustion. Why do these result in the formation of acid rain? So we can look at an example with SOx. So SOx is our sulfur dioxide and sulfur trioxide. When you add these to water, you form sulfurous and sulfuric acid. When those acids are in water, they dissociate and form H plus and some ion. That H plus, remember, you increase your H plus concentration, you're decreasing your pH. So these gases that we are emitting into the atmosphere react with water to form acids, producing that hydrogen ion in water. So why do we care? There are a couple of things that we'll look at. The first is rusting metal. Metal contains a lot of iron. Our steel contains iron. A lot of our metal structures, such as bridges, cars, other infrastructures, contain iron. When we react that iron with hydrogen ions, H+, we dissolve some of that solid phase iron. So you add acid or you apply acid to these structures. When it rains, some of that solid dissolves into an aqueous solution. Something else that occurs, that iron 2+ will react with water to form iron oxide. This is rust. So this is a reaction that causes metal structures to rust. That rust on your car is a result of solid iron being exposed to acid and forming this iron oxide or rust. Another area that we see this is the dissolving of limestone, which marble contains a large amount of limestone. So if we have memorials, other structures, marble structures that have been made from marble, over time, that calcium carbonate in the marble or the limestone reacts with acid. So you're then dissolving that solid, forming aqueous compounds. And you can see this in statues that have been built. This is an example of a statue that was put in place in 1944. You see no pockmarks been present. You see that calcium carbonate has dissolved over time. Acids in the atmosphere, so in tiny droplets before it has been rained out of the atmosphere, also cause issues. These are known as hazes. This is a picture without these aerosols forming, and with the aerosols. These aerosols, this haziness that we see is a result of acids in the atmosphere. Last thing I want to talk about is the effect of increasing the acidity in aquatic systems, specifically lakes. Neutral pH 7, a lot of aquatic systems have a pH of about 6.5 to 9 in this area. Natural lakes, a lot of the pH is controlled, like we talked about in the oceans, those calcium carbonates, but also CO2 from the atmosphere. As we decrease our pH as a result of acid rain, aquatic organisms can have a difficult time functioning. At a pH slightly less than 6, you see many fish species starting to disappear. This is a result of issues with those fish reproducing. If the fish can't reproduce because they are stressed as a result of the acid, then the population is going to decrease. If you continue going lower on the pH scale, adding more acid, you can totally remove all of the aquatic organisms from a lake. So acid-base chemistry is very applicable to our environment and understanding the pH of both ocean water and rain and how this affects both aquatic organisms, but also structures such as bridges that could potentially rust and statues that are made from calcium carbonate or marble.